So now that we've done single unit conversions, meaning we've looked at converting from milliliters to liters or kilograms to grams, what we're going to do now is start looking about converting units that are in the denominator to lead us into double unit conversions. So really one of the main things that you're going to have to do in Physics 50 is convert from kilometers per hour into meters per second. So we just learned how to use dimensional analysis to convert from nanograms to grams. Now what we're going to do is just learn how to convert denominator dimensions so that we can put it all together. So for example, if you had liquid mercury costing $2.15 per milliliter, and we wanted to know how much this would cost per liter, the first thing we would do is write down what we have. $2.15 per milliliter. And this time, instead of changing a dimension that's in the numerator, we're wanting to change the milliliters into liters. And the only thing that changes is that instead of putting the unit that you have in the denominator, you put it in the numerator so that they'll cross out, and then you put the denominator or the unit that you want in the denominator. So for example, if I want to convert milliliters into liters, I'm going to put the milliliters on top, liters on the bottom, and I know that 1 liter is 1,000 milliliters. So then I can type in 2.15 times 1,000 and I get $2,150 per liter. Or if you are using your formula sheet, you could set it up so that you could say, okay, I'm going to go from milliliters into liters, and you could say that 1 milliliter is, right? So you go 1 milliliter is 0.001 or 10 to the negative 3 of a liter. 0.001. So in this case, you'd type in 215 divided by 0.001, and you'd still get 2,150 per liter. So let's just try one quick. So if I have $25 per kilogram, and I want to convert it into per gram. So I want dollars per gram. I want to get rid of the kilograms. I know that 1 kilogram is 1,000 grams. So I know I'm dividing by 1,000. So I would type in 25 divided by 1,000. And I would get 0.025, keeping sig figs. So you would consider this 1,000 to be an infinite number of sig figs. You wouldn't consider it. So we're going to answer with 2. So $0.025 per gram. So that, if we now want to go into double unit conversions, we can. So for example, if I want to go from kilometers per hour into meters per second, I have kilometers per hour. I want to convert the kilometers to meters, and then I want to convert the hours into seconds. So I'm converting a numerator dimension and a denominator dimension. The only thing that people kind of get confused with this is that, you know, maybe you don't know that an hour is 3,600 seconds. Maybe you know that 1 hour is 60 minutes. And then maybe you know that 1 minute is 60 seconds. So what we do is we just do that all in one. We say that 1 hour is 60 times 60, or 300 or 3,600 seconds. That might be something that you want to write on your formula sheet. So one thing you'll notice is on your formula sheet there's a ton of blank space. So you're allowed to write whatever you want down here. Maybe you want to write some things about significant figures. Maybe you want to write that 1 hour is 3,600 seconds. Maybe you want to put an example of dimensional analysis. You can put whatever you want on here. Okay, but I'm going to go 1 kilometer is 1,000 meters, 1 hour is 3,600 seconds. So in my calculator, I'm going to plug in 30 times 1,000 divided by 3,600, and that will give me 8 meters per second to 1 sig fig. Again, these are exact measurements, so the only sig fig that I'm taking into consideration is the one that's in the question, which is 1 sig fig. All right, why don't you try these two? So maybe you want to start with one that's exactly the same. So if you want to go 60 kilometers per hour and then do the whole thing. Or maybe you want to challenge yourself and do this one first. So this one's 5 meters per second and you want to convert. Either way, the first thing I would do is look at your dimensions. So we want kilometers per hour, right? These are the dimensions we want. We have to get rid of meters. We have to get rid of seconds. So then I could put in my conversions. 1 kilometer is 1,000 meters. 1 hour is 3,600 seconds. So the biggest difference is in this one, you're going 5 divided by 1,000 times 3,600 instead of the opposite. This one, again, we want it to be meters per second. We're going to get rid of kilometers. We're going to get rid of hours. So then we're going to say that 1 kilometer is 1,000 meters. 1 hour is 3,600 seconds. And then let's make sure we answer the correct number sig figs. So for the first one, I've got 5 divided by 1,000 times 3,600, which gives me 18 kilometers per hour. 2 sig figs, 2 sig figs. And then the second one, I've got 60 times 1,000 divided by 3,600, which gives me 16.66 repeating, which I want 1 sig fig. Whereas this one I wanted 2 sig figs. And once you learn the sig fig thing, you can't forget it. Okay, so for this one, I'm going to go 1 sig fig, so I'm going to go 20 meters per second. Even though it feels like it would be better to write 17, you can't. You're limited by sig figs. So when you look at your worksheet, there's only questions up to here, but I just wanted to throw scientific System International units into this note as well. What it is that until 1795, the units of measurement were not standardized, and people could use sort of whatever they wanted to, including the imperial system. But then in 1795, we started standardizing, and today we use an adaptation of the metric system called the SI units. So the SI system is made up of our base units and derived units, which is a combination of the base units. So what you're going to notice is that the SI base units are things like the second, the meter, and the ampere. This one we won't deal with until unit 7. Okay, but all of these ones we will. And the biggest thing I want to point out to you is that in physics, our standard unit, or our System International unit, is the kilogram. But in true SI units, the base unit is the gram. So only in physics, because we deal with bigger things, they deal with mass in kilograms. But if you're taking a chemistry course at the same time, you will be using grams. And then these derived units, we're going to be using a bunch of these. So for example, in unit 3, we're going to use the Newton. In unit, where do we see joules for the first time? I think it's 5 for the first time. You know, the watt we're going to look at in unit 5, and the ohm we're going to look at unit 7. So these units are these units of measurement are coming up in different units, but they're all going to be made up of the SI base units. So for example, a Newton is kilograms meters per second squared. A joule is kilograms meters per second sorry, did I say that right? Kilograms meters squared per second squared. A watt is kilograms meters squared per second cubed. And resistance is crazy, right? Kilograms meters squared per second cubed per ampere squared. What? Instead, they call it the ohm. So these are derived units from equivalent SI units, but we will deal with those later. They're just kind of good to mention in a video at some point.